Hey, how's everyone? I hope you are doing great. This is Nirmit, and today we are back doing question number 3558, number of ways to assign edge weights 1. Now, this is a very nice question. It helps you revise some very key concepts like about the graphs, how to find the depth of the graphs. It also helps you revise binary exponentiation and key binomial theory concepts. So yeah, let's jump into the question and yeah. So this is an undirected tree with n nodes labeled from 1 to n at node 1. The tree is represented by a 2D integer array edges of length n minus 1, where edge I is equal to ui vi, indicating that there is an edge between ui and vi. Okay, so and initially all edges have weight of 0. You must assign each edge a weight of either 1 or 2 only. The cost of path between any two edges uv is the total weight of all edges in the path connecting them. And we have to select any one node x at the maximum depth and return the number of ways to assign edge weights in the path from node 1 to x such that the total cost is odd. Okay. And the number may be large, so we have to return it modulo 1 plus 7. Cool. And we have to ignore all the edges not present in the path from 1 to x. Okay, very well. So let's jump onto the whiteboard and understand our question first. So see, this is what our questions look like. We have a graph, and you have to see what is the maximum depth in the graph. So here, just a second. Yeah. So here is, if you see in this graph, the maximum depth is 1, 2, 3, 4, 5. 5 is the maximum depth. So you can assign weights to these edges, 1, 2, 3, 4, 5 edges, such that the sum of weights along this path is odd. So how can we do that? We can only use one or two. So if you have if you have five numbers and you can only have one or two, we can have it multiple ways. Suppose we have it one, two, just a second. One, two, two, two. This is one way where we can have odd. We can have one, one, and four twos. Then we can have, if we have two, one. So in that case, it will become two, and the remaining two will also contribute to. So it will become even. So we must always have odd number of ones. So then we have three ones and two twos, and finally we can have five ones and zero twos. Now these three are the ways in which we can have some of weights along the maximum path as odd. Now this 1 to 2 can also be written as uh, 2 1 2 2 2 1 2 2 2. Then it can also be written as 2 2 1 2 2 and so on. So if you remember your concepts from binomial theorem, this is 5c1, number of ways of selecting one number out of five number, and then this is 5c3, number of ways of selecting three numbers out of five numbers and then placing them at certain positions, and then this is 5c5. So our sum becomes 5c1, that is 5, plus 5c3, that is 10, plus 5c5, that is 1, and our answer becomes 16. So this is how we can find the number of this is how we can find the number of ways to make the the sum of weights along the maximum path odd. Now for each question we have to find maximum depth of the tree, that is clear. But are we every time going to compute nc1 plus nc3 plus nc5 up to ncn? That will become computationally very heavy. So now here's where our binomial theorem comes in. So we all had studied in our 11th, 12th about binomial theorem. Like for the Indian students, basically we had actually where the sum of powers according to binomial theorem, like nc1 plus nc2 plus nc3 up to ncn, is equal to 2 to the power n. Now, when you put x is equal to minus 1 here, the theorem is basically 1 plus x raised to power n is equal to ncr xr. When you substitute x for minus 1, it becomes something like this, and since 1 minus 1 is equal to 0, so this is effectively 0. And when you rearrange them in certain ways, it's basically becomes sum of odd indexes is equal to sum of even indexes, that is nc1 plus nc3 plus nc5 up to ncn is equal to nc2 plus nc4 up nc6 up to ncn minus 1. So that's how we are getting this. And yeah, when n is so both are equal and their sum is 2 to the power n, so this basically implies that each one of them is 2 to the power n minus 1, because 2 to the power n minus 1 plus 2 to the power n minus 1 will give you 2 to the power n. So that gives us that sum of odd edges, like sum of number of ways of that, like sum of all the index terms will be 2 to the power n minus 1. So if n is odd, then ncn plus ncn minus 3 plus ncn minus 5 plus nc up to nc1 nc3 nc1, will be 2 to the power n minus 1. So that's what basically our question is now. We will first find the edge, we will first find the maximum depth of the tree, and then we will just do to the power n minus 1 there and get our answer. So yeah, let's jump to coding. Our constants are also true 10 to the power n less than 10 to the power 5. So we cannot think of any n square approach. We can do maybe big O of n or big O of n log n. So let's start coding. First of all, I've been given edges. So I will here create a adjacency list, which I will be traversing to find the maximum depth. So vector int adjacency list, and it will be of size n plus 1 because indexes here are 1 based. And yeah, one more thing, n minus 1 is size of edges because n minus 1 edges are there. So I will just add a plus 1 here. So it will be equal to number of vertices, and then I will traverse through the edges for auto and x through edges. Now here I'm using and x because I'm passing it by reference so that a different copy of it is not created in the memory and to save some space and time. And u is equal to x0 and v is equal to x1. Now since this is a undirected graph, so both of them will be pushed in the adjacency list of another one. Like this, adjacency of u push back adjacency of v and adjacency of v dot push back adjacency of u. Now, once I had created the adjacency list, now our next path, next job is to find the maximum depth of the tree. So I will just create a variable answer is equal to 0, and then I will pass get edge, and then I will pass my nodes to this to get the maximum edge. Let's create that function to get the maximum height of the tree. Get edge. What we will need here, we first need a node which we are passing. We'll need the parent of that node. We will need the current height that we are having. We will need the maximum height, which we will be passing through reference, and then we will need the adjacency list. So yeah, we now let's just quickly pass everything here also. We are passing 1. Its parent will be 0 as it doesn't exist in the list. Our height currently is 0, and here we will pass answer and adjacency list. Now, how to get the maximum height? Simple. We will just traverse through this adjacency list. Yeah, first of all, answer will be equal to maximum of current answer, current answer and the current height. And then I will traverse through all the edges in the current adjacency list of this node. And once I do that, I will check if the current node that I'm getting is it a parent of X already? Because if it is already a parent, there is no need to traverse it again. But if it is not, then I will go on that path and check if that is the if maximum depth is along that path. X, and now its parent will become node, its height will increase by 1, and then the rest will be same. Here, if you note, I am passing this again by and I'm passing it by reference because I don't want it to create a different copy of it because it will just unnecessarily take extra space, which we don't want. We want the best optimal solution with best time and space complexity. So yeah, this will give us our optimal height. Once we have gotten our optimal height, we just have to return 2 to the power n minus 1. So our answer will be basically 2 to the power n minus 1. That is answer minus 1. So I will just use binary exponentiation to get more optimally the power. I will just create a mod because I have to create answer 1 in 9 plus 7, 10 to the power 9 plus 7 mod. Now I will create the function for getting the height. So in solve, I am having here int x, uh, int x and int n. Now I will just quickly assign a variable where I will store my answer. I will quickly write the algorithm of binary exponentiation. So let's do that quickly. While n greater than 0, if we have a 1 bit here, we will just multiply our answer with x and do percent mod at every step so that there's no integer overflow. Otherwise, I will just continue. X is equal to x into x percent mod. And at the very end, I will just shift by 1 bit to the left. At the end, I will get my 2 to the x to the power n with percent mod. That pretty much will solve our algorithm. Let's run it. Okay, we have done some minor errors. Let's fix that. Yep. Now our algorithm is perfectly running. Let me just submit it. Yeah, and that's how we solved it optimally. We have a nice. Yeah, so our problem got submitted. Our solution is accepted. I hope you enjoyed the video and got new concepts to learn. If there's anything else I could help you with or anything else you need to learn, you can reach out to me in comments and I would be glad to help you. Thank you. Signing off.